We have a lot of reactions here. We have 1, 2, 3, 4, 5 reactions to actually go through. And we are going to always think about Markovnikov and anti-Markovnikov and the final product of the reaction. The first one right here, this reaction is called a hydrogenation reaction, more specifically catalytic hydrogenation because we need the catalyst, palladium or platinum right here. But we're going to be adding hydrogens across the double bond, so the final product of this reaction will not have the double bond right here. It'll be just pentane. This is going to be a syn addition of hydrogens, so the hydrogens are going to be added to the same side of the double bond. Now the second reaction, it's what we call a hydration reaction because we're adding water across the double bond. We're adding the elements of water, so we're adding one hydrogen to one carbon and the OH to the other carbon. And this one right here is a Markovnikov addition. So we know that the hydrogen is going to go to carbon number 1 because carbon number 1 has how many hydrogens? If you answer 2, that's correct. So carbon number 1 has 2 hydrogens, carbon number 2 has only 1 hydrogen. It would be good for you to try the mechanism, but we add the hydrogen on carbon number 1. The OH goes on carbon number 2. Again, this is a Markovnikov addition, so always remind yourself of those little details when you're doing something like this, which I would call a little spider. It doesn't resemble a spider, but it looks like a spider. The addition of a hydrogen halide is also another reaction that follows Markovnikov. So again, we're going to put the hydrogen on carbon 1, and the chloride, we're going to attach it to carbon number 2. You don't have to draw the hydrogen. I'm doing the adding the hydrogen and writing it so that you see that both atoms of the double bond get something new attached to them. Alright, so this is a Markovnikov addition just like the previous one. Both of those are going to have carbocation intermediates, and if they both have carbocation intermediates, both of them can suffer from rearrangements. Now this reaction right here, it's called a mercuration-demercuration reaction, and this reaction will not suffer from any rearrangements. We're still adding water to the double bond. We're still doing it in a Markovnikov way, but we won't have any rearrangements. Not that this particular alkene can rearrange, but we're gonna, pretty soon I'm gonna do a video of one that can rearrange. But you're always going to remember 2 things about this reaction. It's a Markovnikov addition, and I also wanted to make really clear that it will not have any rearrangements. You need to remember those little details. The last one is a special reaction. It's an anti-Markovnikov reaction. We only have 2 anti-Markovnikov reactions. So on this one right here, the hydrogen will go on carbon number 2. It will go to the carbon that has less hydrogens. It does the opposite of Markovnikov. And the OH will go to the outside. This is not a carbocation reaction. You need to know the mechanism of it, but it's important that we remember that it's one of only 2 anti-Markovnikov reactions that we have in this chapter. Alright, practice all these reactions again with different alkenes. You need to remember the reagents, and you also need to remember the little details about all the reactions. So practice with different starting materials.